Welcome back to PPD. Now we are in the last stage of Relational Algebra series. We are going to learn about compound operator division. And yeah, let's dive right in. So we are going to speak about compound operator division. So whenever we are speaking about an operation in relational algebra, the first thing I did was to introduce you the notation. Okay, whenever I spoke about selection, I introduced the notation sigma. Like for projection, it was phi, and union, and we had set difference. Also, we had cross product, naming, renaming operation, and we also had some other operations which are compound. They were intersection and natural join. We had also theta join. Sometimes we also had eq join. But now we have come to another important operation which is called division. Division has this notation. We can also use this notation in basic in some other conventions, but I'm going to use this convention here. You can also use the division symbol if you want it. Okay, so now let's start with compound operation division. Actually, division is a little bit of a complex operation. Let's look at it from the definition. Let's start from the definition as we always do. Division. This is used for all operations, mostly for all queries. This is used in for all queries. Okay. What do I mean by that? Well, for all is a universal quantifier. In math world, we use the notation inverse A, inverse A to mention for all. So here the for all means a basic idea, okay, that we can use to understand the relationship between entities in two relations. Okay, we know we call the tuples sometimes as entities. Okay, we call tuples as entities in relations when we are speaking about the interaction between other relations entities. So let's say we have a relation called relation 1, and let's say we have another relation called relation 2, and if these two are related with each other, we can actually come to a conclusion to say which entities of relation 1, which entities which entities of relation 1 is related to all the entities in relation 2, related to all the entities of relation 2. For example, what I mean by this is, let's say the relation 1 is something like this. We have x and y attributes, and we have 1, 100, 2, 101, and 101, and 2, 101, and 3, 100. Let's say it's like this. And let's say relation 2 has only one attribute y, and it has 100 and 101. Here, this 1, the entity 1 is connected with 100, is related to 100 as well as 101. Okay, 1 is connected to 100 and also 101, the values that are present in the y attribute in relation to. So the idea is, the concept we are going to learn is, the entity 1 is actually related to all the entities in relation to. Similarly, you can look at 2. 2 is also related to 101 as well as, we can change this to 100, as well as to 100. So 2 also related to all the entities in relation to. But if you consider 3, 3 is only related to 100. Therefore, it is not an entity in relation 1 that is related to all the entities of relation 2. And this is why we use division. Okay, so the syntax is relation 1 divided by relation 2. This is the syntax that we use for division relational operation. Okay, so to give in normal formal English words, we can say division helps us to find entities in one relation which are related to all the entities of other relation. Okay, relation 1 divided by relation 2, or you can say relation 1 divided by, you can use this notation to mention that, relation 2. This is what we call division. But when we started studying about union or set difference operation in relational algebra, you should remember we spoke about some condition, and that condition was called union compatible. And similarly, here also, if you want to apply division, there are some requirements that should be met. So first of all, I will write down the syntax for two relations called A and B. A divided by B. The first thing that is considered is A has attributes X and Y. X is looking like cross product, so I'll use this one. X and Y. And B has attribute Y. This is the first and foremost requirement that should be met if you are applying division relational algebraic operation on two relations called A and B. This is a very important condition that should be met. This can be given as A x comma y and B y. This is very important. Okay. And here the attribute y is a subset of attribute y is a subset of relation A's attributes. Relation A's attributes. Keep that in mind. And the result will be, this is the main condition, and here we also have a subcondition because y is a subset of our relation A's attribute, so that's very important. So the result will be, the result of A divided by B will be the relation that contains only the X attribute values. X attribute values, attribute or column values, X attribute values, X attribute values that relate with every single attribute, every single value in Y, that relates with every single value in Y attribute of relation B. This is the result, resulting relation. This is input query. This is resulting relation. And A and B are the input relations. Okay. So this is all fair and all. This looks okay for us. Okay. But since we are learning compound operations, we should know how they are actually made by using basic operations. That's the important thing that we are learning throughout this series. So let's start with the steps. Okay. So what is the story behind division? A divided by B. The first step will be, okay, the first step will be, we will be projecting out only the X attribute of A, X column of A. That's what happens first. First of all, we will reduce the A relation into two parts, okay, which only includes AX. Okay, X attribute of relation A. So, visually speaking, first of all, I'll write the notation project X attribute of A. This is the first step. Okay, this should look like something like this. Okay, I'll draw the relation. First of all, let's draw the relation A and B first. Okay, let's say A relation looks like this. A relation looks like this. We have X, we have Y, 1, 2, 1, 2, 3. And let's say there are Y values 100, 100, 101, 101, and 100. Let's say B relation looks like this. All right. Let's say it has Y value 100 and 101. Let's say like this. Okay. Since we are projecting, the first step is we are projecting only the X attribute of A. Let's name that as AX. That relation as AX. So AX will be what? We'll have only X values, which will have 1, 2, and 3. 1, 2, and 3. These are repeating values. 2, 2, 1, 1. These are repeating values. So we can only have one time. This is the first step. And the second step will be, we will be cross producting. We will be applying cross product on AX and B. This is the second step. What happens when we cross produce, we use cross product cross product operation on AX and B? We have AX and B, so it will look like X and Y. Obviously, these are the two columns. So let's start with, this is zero step. This is also zero step. This is first step. And now we have second step. Second step should look like this. AX into B must look like this. We have X and Y. X has 100, 101, 200, 201, 300, 301. This is what we have when we use cross product on two uh, relations called AX and B. This is the second step. Now you can barely understand, or you can guess where this is actually going. Okay, so the third step will be, we will be, let's say this is maybe all the candidates. Let's say these are the candidates. Let's say C. Okay, and now what we are going to do is, we are going to find the missing values in A. Missing values in A. Missing values in A. So we can say C minus A. This will give us the missing values, or we can say the disqualified tuples. Okay, these are the missing values. So let's say this is M. So the third step will be, we are finding the set difference. We can use the word minus. Okay, we can use the word minus when we are speaking in relational algebra. We can use the word minus to say set difference. So that's good. So C minus A will leave us with what? C minus A will leave us with X, Y, only 301. 301. Set difference now உங்களுக்கு தெரியும் தானே? You should remember that. What happens in set difference? If it returns the tuples that are present in relation 1 that are not present in relation 2. This is the relation 1 in this case. C is the relation 1. Here we have 6 tuples and here we have 5 tuples in A. Only 301 is not there in AX into B. That's why we are taking this out. Then we will find the disqualified X values. We are going to find the disqualified X values. How can we do that? We will project by only the X attribute of M. Okay, this will be the disqualified values. So the disqualified value will be X3. So this is disqualified. This one is disqualified. This one is disqualified. Now we can actually do the set difference again and find out what are the qualified values. So we are going to do set difference again. How? From AX, we are going to minus the disqualified values to find the qualified values. So the fifth one will be ax minus d, which is q, which will give us x, 1 and 2. So the final output of a divided by b will be equals to q. I have broken down into very simple steps. Okay, very simple steps. You don't have to do this way. Okay, you can just directly apply this and do. But or you can combine two operations. You can combine two operations to find the answer, or you can come up with a formal definition or formal expression for this division, like I'm going to do in few minutes. But this is the basic 5 steps. You can combine these two if you wanted, but I use these 5 steps just for my easiness. Okay, so now I'm going to introduce you to the uh, formal definition by using all these ideas. So from this, we are going to understand what the expression for expression for division. Okay, so let's try to understand the formal expression. So if we have a divided by b, right? If we have a divided by b, we know that if we have a and b, we also have come up with the d. Yeah, we have come up with the d, the disqualified contents. Yeah, disqualified contents here. So since we have disqualified x values, we can say we just need the ax minus d. That's what we need. That's the idea that we came up here. But we don't know what d is, இல்லையா? And we also know what ax is. So instead of using ax, I'm just gonna say pi x a projects the x attribute of a minus the set difference part minus, okay, project the x attribute of d. ஓகே, ஸோ நவ் யூ ஹாவ் அ டவுட், எப்படி நீங்கள் எக்ஸை மட்டும் எடுக்கலாம் அப்படின்னு சொல்லி நீங்கள் கேட்குறீங்க, சரிதானே? ஐ கேன் அண்டர்ஸ்டாண்ட் தட். பட் இன் திஸ் கேஸ் வி ஆர் கோன் சே வி ஆர் கோயிங் டு ஆல்சோ இன்க்ளூட் what d is also. Okay, so in the formal expression you will say a has x comma y attributes and b has y attribute, where y is a subset of x comma y. Okay, so this is all formal expression. So அப்போ d வந்து நாங்க வந்து எக்ஸ்பிளைன் பண்ற மாதிரி இருந்தா, see d is actually they have given pi of x of missing and we are not going to write this missing part. சரிதானே? இந்த ஒரு ஸ்டெப்பை வந்து நான் என்ன பண்ண போறேன்னா, ரெண்டையுமே நான் வந்து சேர்க்க போறேன். அப்படியே இதையும் சேர்த்துருவோம், ஒன்றும் பிரச்சனை இல்லை, சரிதானே? ஸோ என்ன செய்ய போறேன்னா, d வந்து அதாவது டிஸ்குவாலிஃபைட் வந்து என்னவா இருக்க போகுதுன்னா, ஆக்சுவலி இட் வில் பி c மைனஸ் a இல்லையா? ஸோ pi of x of a into b minus a, that is equals to d. This will be equals to d. Okay, அதாவது என்ன செய்யறேன், இதுதான் வந்து ax. ஸோ ஏஎக்ஸையும் பியையும் கிராஸ் ப்ராடக்ட் பண்ணா எங்களுக்கு கிடைக்கிறதா வந்து சின்னு நாங்க பார்த்தோம், சரிதானே? ஸோ அதை நான் வந்து உடைக்கிறேன். இன்ஸ்டெட் ஆஃப் இன்ட்ரடியூசிங் நியூ வேரியபிள்ஸ், ஐ எம் ஜஸ்ட் கோயிங் வித் த ஃப்ளோ. ஓகே, சரிதானே? ஸோ அப்போ பை ஆஃப் எக்ஸ் ப்ராஜெக்ட் எக்ஸ் attribute x of a and cross produce with b minus a. So this will give me d. Okay, this will give me d. சரிதானே? So this is how I'm gonna use the formal expression. Okay, so this is easy இல்லையா? single steps நம்ம வந்து formal expression எடுத்துக்கிட்டாச்சு. So this is easy. Now we will look at a practical example. So here we have a relation A which has sailor ID and boat ID, and the sailor ID is 1, 2, 3, and there are boat IDs 101 and 102. So let's say relation B. Okay, let's say relation B is just boat ID. Then only we can apply division இல்லையா? So it will have 101 and 102 for me. Yeah, it has 101 and 102. If we want to find out A divided by B, okay, so we have to find what? We have to find A divided by B, which means every x instances. Okay, every x values that are related with all the y values. Okay, so இப்போ 1ம் 101ம் கனெக்ட் ஆகுது, 1ம் 102ம் கனெக்ட் ஆகுதுன்றனால அவுட்புட் வந்து a டிவைடட் b யோட அவுட்புட் வந்து என்னவா இருக்கும்னா செயல் ஐடின்னு வந்து எங்களுக்கு என்னென்ன வந்திருக்கணும், 1 வரணும், அதே மாதிரி 2ம் வரணும், ஆனா 3 வரக்கூடாது. ஏன்? 3 வந்து 101ஓட மட்டும்தான் வந்து it has a relation. The link is between 3 and 101, only one. Without the 3 doesn't have a relationship with 102. So let's use the formal definition here. Okay, the formal expression. Since a has x comma y, here x is Sailor ID, y is boat ID, and we know b has the y column. Okay, we can say these two are okay. Well, first of all, we just keep like this. Okay, so a divided by b is equals to pi project x attribute of a minus project x attribute of d, where d is equals to project x attribute of a multiplied by b, and we have to, from that we have to minus a. Okay, so we have relation a and all these things. Okay, so project x attribute of a, project x attribute of aன்றது வந்து தான் முதல்ல நடக்க போகுது. ஏன்னா அதுதானே வந்து parenthesisக்குள்ள இருக்கு. ஸோ அப்போ அதுதான் வந்து முதல்ல நடக்க போகுது. ஸோ அது நம்ம பார்த்த மாதிரி இருந்தால் அதுக்கான அவுட்புட் வந்து வரப்போகுது செயலர் ஐடி 1 2 3 வரப்போகுது. அண்ட் we know இந்த ப்ரொஜெக்ஷன் ஆப்பரேஷன் duplicate tuples will also be eradicated. So that's not an issue. இப்போ நமக்கு வரப்போகிறது pi of x, I mean project x attribute of a multiplied by b. This will give us Sailor ID and boat ID. Sailor ID, here is the relation b. So boat ID 101, 102, 201, 202, 301, 302. Okay, so this is the next step. And then we have minus a. Okay, from this we are subtracting, we are minusing a. Okay, and if I minus a from this, what will be remaining? Well, this one and this one will be gone, 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 this one and this one will be gone. So the output will be Sailor ID, boat ID 302. Okay, so this is equals to d. So this is equals to d. Now we need this one, which is this one, and from that we are minusing this one, which is by project x attribute of d, which is just Sailor ID 3. Now we can say, if I the set difference process here also, 3 will only be cancelled. 3 will only be cancelled. So 1 and 2 will be the output. So the answer will be this one. Okay, the answer will be this one. Look, it's the same as this one. So this is why I taught you the formal expression by using the basic relation operation, basic relational algebra operation. Okay, so this is how you have to perform. Division in relational algebra. Thank you for watching and supporting the Relational Algebra series. If this series added value to your learning, don't forget to give it a thumbs up, share the knowledge, and subscribe for more ICT and database tutorials. I'll see you with the next playlist. Until then, keep learning and stay curious. Bye bye.